Hi, I'm Patrick. I started the company Algorithmica Technologies some 10 years ago to bring machine learning methods from the ivory tower into industrial application. And I'd like to tell you about the intelligent process control application that we've recently developed to improve the control over an industrial process in power chemistry and petrochemistry plant environments. You want to control things. For instance, you want to control that certain parameters stay level. And a number of other parameters have to be changed in order to keep something level, because the environment always changes. We have various parameters over which we have no control, such as the weather, or the quality of raw materials, or maybe the purchasing department has selected a new supplier for certain raw materials. Maybe something gets damaged further in the stream of the product, and the things that come at a different speed, a different throughput. And so things have to be adjusted, set points have to be changed in the process for the important variables in your process to stay constant. And that has to be regulated, it has to be controlled. There are a number of applications available in advanced process control that can achieve this, but there are limitations. Those limitations are primarily on two accounts. Firstly, that you have a limitation on the number of independent variables that you can introduce into this process. They're usually limited to very few, something below 10 usually. So that these advanced process controls are very, very local in the process and can handle usually one piece of equipment only. The other aspect is that you're usually asked to make so-called step changes in order to construct the model behind such controls. That means you have to perform a number of empirical experiments specifically targeted towards designing that advanced process control application in your process. This is particularly expensive because there are a number of settings that you have to make for these step changes that you really don't want to do. You have to explore the extreme regions, basically, of your process to do it. Our answer to these two limitations is to say, first of all, we can produce a mathematical model that includes an unlimited number of independent variables. You can include hundreds upon hundreds of independent variables to still control a single output value. So you could, in fact, take into account the entire plant if you wanted to. The second aspect of performing enough empirical experiments is simply this: you've already done them. All you have to do is look hard enough at the historical database inside your archive system for the last few years, and you will find in every plant that I have looked at, this has been the case, that all the extreme points of the process have been explored for one reason or another. All you have to do is find these measurements in the database, so you don't have to go through a lot of human-intensive and costly measurements specifically targeted towards that controller application, because all you have to do really is provide a database dump of the historical measurement archive, and if the software is intelligent enough to extract this information from that database, that model can be constructed purely from information that you already have. And that's why we call it intelligent process control, because our application is in fact intelligent enough to extract this information from the database. It does that by teaching a neural network to encapsulate the relationship between the variables involved, between the independent variables that can be used to adjust what I want and the variable that measures what I want to either keep constant or what I want to keep at a maximum or a minimum. It is comparable to a thermostat in a heater. The thermostat receives the information of how warm the outside and the inside temperatures are, and it adjusts the opening and closing of the valve in the heating in such a way that the inside temperature is maintained at the constant level that you have set it to be. So if the outside temperature gets colder and therefore the inside temperature drops off, the controller will notice this and open the valve for more heat to be provided to the room, and so the room temperature is kept constant. This kind of behavior is very simple in the industrial context. Of course, that interaction is much more complicated because we're not dealing with one independent variable, the outside temperature, but we're usually dealing with quite many around the process, and therefore the interaction is nonlinear and complicated and has to be carefully sorted out for the application to understand. But this understanding, or this information for the basis for this understanding, is contained in your historical database, which we will extract. So I invite you to try out the application. It's just a simple software package. You can download, install, provide the historical data, and the application will learn on its own without your participation, but will demonstrate to you that the model is in fact complete and accurate and precise. So please have a look at our website, where you will find more technical information regarding this, and you will also find reference case studies where you can read about what we've done with various clients in the past, how we have achieved a good control application for them, and what that has gained for them in terms of financial output. Thank you very much.